Alrighty, students. So we are going to go ahead and start off with the skill check section again. Um, Hopefully you're doing this work in your spiral. I have seen some work submitted in just loose leaf paper. The hope is that you are creating a piece of material that you can study in the future if you need to. But if loose leaf paper works, if that's what you got, that's what works. That's cool. All right, so skills check. Let's go ahead and start off with that. You got a couple basic equations, two-step equations that you need to solve here. Factoring each expression. Notice it's an expression. There's no equal sign, and you're like, wait a minute, factoring. Oh shoot, I think I kind of remember factoring. Jump to the chapter previous, or flip back in your spiral and you'll see we've done a lot of factoring here. So we're just trying to get you warmed up because this whole section is factoring to solve quadratic equations. One new vocabulary term, the zero product property, and you'll want to add this to your vocabulary Google Doc. Okay, first example, and the zero product property. Now the zero product property says for every real number a and b, if a times b equals 0, then a equaling 0 then A will equal 0 or B will equal 0. Okay, two non-zero factors multiplied together cannot give you 0, right? 1/2 times -1/8, it's not going to give you 0. Like, try any combination you want, product of the two, unless one of them 0, you're not going to get 0. So here's something that is also true. It doesn't have to be just two factors, A and B. If there are 7 factors and any one of them is 0, then the whole thing is 0. Okay. So if it's, x, y over z times a times the square root of -g, it doesn't matter. If any one of those factors is 0, then the whole product is 0. All right. This is just something that's important to know. In this particular situation for this chapter, we are going to be looking at very few factors, typically 2, and those factors will be binomials. All right. So example 1, using the zero product property, solve, and they've given us the two binomials for us. Solve x plus 5, the quantity, times the quantity 2x minus 6 equals 0. Solve that. Solve that quadratic equation. So the way to do that is you take both of those factors and set each of them equal to 0, and then solve for the x that would make that factor equal 0. So you can see here on the left, excuse me. So you can see here on the left, we have x plus 5 equals 0. They don't show their steps in their work, but um, I'll just go with it. Subtract 5 from both sides, and you find out that x is could be -5. Or if the other factor equals 0, then you add 6 to both sides, divide by 2, and you find out that x could be 3. So we have two possible solutions. X is either -5 or x is 3. Either one of those will make this quadratic equation true. All right, and you can check it out by substituting in your answers and seeing that it's true. All right, so you have quick checks down there at the bottom. You have 4 quick checks. Give those a shot. Example 2. In example 2, they're saying, hey, oops, you know what? We're not going to make this easy on you and just give you the factors right away. We're going to give you the quadratic equation and factor it out. So here we go. This is a fairly easy one. What are the factors of 8 whose sum gives you a positive 6? That's 2 and 4, pretty straightforward. So you factor this into x plus 2, x plus 4, set each of those equal to 0, solve for the x that makes either one of those factors true. If it equals 0, that makes either one of those factors equal 0, solve for the x that makes that happen. And you find out that x is either -2 or x is -4. Number 2, quick check 2, they're only giving you 1 this time. They want you to solve this by factoring. So you're going to factor this out, um, reversing out, and two factors are set each of them equal to 0. So this sentence is actually a prelude to example 3. But before solving our equation, you need to add track terms or equations. then factor the quadratic expression. Notice in this case, they've already given it to you in standard form because we have this little, super helpful equals 0 right here. We're ready to roll. Example 3, that's not the case. Example 3, we have 2x squared minus 5x equals 88. 88, last time I checked, wasn't 0. So in order to make it 0, we subtract 88 from both sides. Quadratic equation. And now we factor out 2x squared minus 5x minus 88. We find out that these are the two factors of that quadratic equation. Set each of those factors equal to 0. We have a two-step equation here. We find out that x could be negative 5.5 or x can be 8. Notice how here we have that step to make this in standard form where we have this polynomial equaling 0. All right. Now, this leads us into the next one, right? I mean, it's just layered. Hopefully, you've picked up on that now, that we're just building layer on top of layer. Because real world situation, we have sort of formula and sort of value. Rarely do we have everything neatly packed for us with an equation that equals 0 or with an expression that equals 0. Okay. So get the first layer. It's the only difference between number 3 and number 2. Final quick check, number 4. This is a biggie. Real world problem solving. Okay, so we need to manufacture a three-dimensional box. I don't know, Amazon box, and have slab material, so cardboard. And in order to make our box, that is exactly 3 inches high. Right here, the height of the box is 3 inches. So in order to do that, we need to cut off 3 inches and 3 inches from both the length and the width so that these remaining flaps can be folded up and we have this three-dimensional open box. Now, obviously, there's flaws with this, where are the tabs? How's it going to stay together? We just going to wrap this thing in tape to hold it together? You got to ignore all that for the math problem. Okay, so just open top box, cutting off some corners, fold up the flaps. We're good to go. All right, now what's interesting is in the problem, they never actually state that the length has to be 2 more inches long than the width. Normally, that would be a given in some sort of narrative or exposition here in the problem. They didn't give it to us. They just give it to us here in the diagram. So what we know is that the material, the area of the material, is 288 square inches, which means the length of the material times width of the material equals 288. I just with the length of the material. What we do know is that the width of the box is going to be x, and since we cut off 3 inches from both sides, this width of the material is going to be x plus 6 right here. Width of the material, the x width of the box plus the 3 inches that we cut off on each side gives us x plus 6 for the width of the material. Only difference for the length is that the original length of the box is x plus 2. We still add back the 3 inches that we cut off on each end, and we end up with the length of the material equaling x plus 8. So what's our equation? Length times width equals area. Basic rectangle area equation. So here we have our length, here we have our width, here we have our area. Go ahead and FOIL those guys out. Subtract 288 from both sides. Factor what we have left, not what we have left. Factor basically the quadratic equation now in standard form because we subtracted 288 from both sides. And we find out the factors of this are x plus 24 and x minus 10. We set each of those equaling 0. We do the work to show this negative value, even though the negative value makes no sense because we're not going to have material that is negative 24 inches. We're only going to have material that is actually 16 inches wide. All right, is that 16? Yeah, it should be 16 inches wide. So the only reasonable solution, so the original question, find the dimensions of the box. All right, I found the dimensions just now of the material because it's going to be x width plus 3 plus 3. So the material is 16 inches wide. But did you see how I wasn't answering the question? Oops, the question was, what are the dimensions of the box? So we know this dimension is x is 10. This dimension is x plus 2, so that's going to give us the 12. And then the third dimension, or the height of the box as those flaps fold up, is 3. That's given in the problem. All right, your job in quick check, sorry, I keep doing that, quick check 4, is to suppose that you have a box with a base and a width. The width of the base is x. The length of that box is x plus 1. So just imagine the same exact diagram, just with x and x plus 1 instead of x and x plus 2, and a height of 2 inches. It is cut from a rectangular sheet of material with the area of 182. This is basically the same exact problem as the example. Not a whole lot of thinking here, just basically recreating what was done in the example with different measurements and different numbers. All right, you got this. You can do this. The problems in the exercises are going to be a little tough. So that is it for instruction. If you have any questions, ask in the class comments. And if that doesn't help, then send me a message.